Welcome to the periodic chart. We're going to review some important parts, but the most important is to take note of the stair step on the right-hand side. I made this one extra dark, so you don't normally get such a dark version of it, but if it helps you, go ahead and make the one darker. You want to have a periodic chart in front of you for this video. You want to use the blank one that comes with the course that you can just download, and then you want it to be in your handwriting. And if you want to add colors, that's great, but you don't have to. It'll help you on the homework coming up in the future, and you may even want to screenshot it and have it on your phone for homework that you get done. So we're going to go through some really important parts of the periodic chart. So this is kind of the easy part here. We have one section of the chart that is considered metallic or metals. It bumps up to include the aluminum. I'm going to include some of these lower ones, but things are a little funny when you get to the very bottom of the chart. This is our metal section in here, and I'm just going to write metals. And just so that you know, when they form ionic stuff, they like to go positive. And I know you don't know what ionic is, but this might be a helpful note to you for the future. And the other option is going to be over here in this section that isn't colored in. This is non-metal. And these ones for ionic like to go negative. So the two sides of this chart, it may seem like I'm just making a quick little comparison here, but actually these two sides of the chart are kind of huge in how the different elements do bonding. It's different in how we name them. There are just so many things that are different depending on where in the chart an element comes from. So it's really important to know whether or not you've stuck a metal with a non-metal or just two non-metals together. You've already learned about groups and periods, so I'm skipping past that section. Sometimes groups are called families. The two tall columns on the left have similar names. One is the alkali metal and one is the alkaline earth metal. Come over here, the halogens. And then these are the noble gases. There's a few elements that have some unique properties on the chart. We're going to kind of color code the two liquids. So mercury is one of our liquids, and bromine is one of our liquids. Now, a lot of people who work with medical equipment or medical people, they'll say, oh, but iodine's a liquid. Well, actually, it's a purple crystal, and it's really, really sparkly. If you put it in like a glass container, put a lid on it, you'll see it just kind of start to sublime a little, make like a purple cloud around it. It's really pretty. But if you dissolve it in the right solvent, it'll turn like the solvent with the crystal, like it will dissolve and it'll look brownish colored. That's what they use when they're putting on stuff on people in the hospital. You should also know where the gases are on the periodic chart. This column is called the noble gases, so that makes it easy. So these ones are all gases. And then we also have NO and F and chlorine and hydrogen. Everything else on the chart is a solid at room temperature and normal 1 atm pressure. Make sure that when you're looking at a specific element, you're aware that this right here is the atomic number. And remember, that is the number of protons. This number right here, this is the weighted average. It's the atomic mass. Something you may not have noticed is that some of the masses on the chart don't have decimals with them, and instead they have brackets around them. So all of these, and then all of these, and there's one in the middle right here. Those are elements that are completely radioactive. They're unstable. And what's in the brackets, mass of the longest living isotope. Go ahead and mark these regions I'm about to mark. This is the S block, and it means that the valence electron falls in an S orbital. This right here, the other set of tall columns, this is known as the P block. And again, it's the valence falls into that P orbital, the valence electron, the farthest out valence electrons do. This right here is known as the D block. and this is known as the F block. Something else to note is that right here, this is a 57 and this is a 58. Notice right here, this is a 72 and this is a 71. Those actually fit like this. So there's your 57, 58, and then your 70 and your 71. So this is just, the numbers get so small when you have a chart that is so long that it's just not practical to have it all on one sheet of paper. So that's why we use this chart here. This row has a name because of this one. These are called the lanthanides. This row's name, again because of this one, these are called the actinides. This whole F block here is also known as the inner transition metals. This D block is also known as the transition metals. And there you have it.